Okay, so today we're going to start solving inequalities and we're going to use addition and subtraction. Okay, so just like we use the properties of equality to solve equations, we're going to use the properties of inequality to solve inequalities. Okay. So the idea of an equivalent inequality is just that the inequalities they're inequalities that have the same set of solutions. Okay, so if we move down to this little table here, the first one we see is the property or the addition property of inequality. So if I were to say, so if we have A is greater than B, then we would have A plus C is greater than B plus C. Okay, and the same if we have A is less than B, then if we added that C in, we would have A plus C is less than B plus C. It's kind of the same thing as when we use our properties of inequalities, or our properties of equality when we're solving equations. So if we have 5 is greater than 4, then we also have that 5 plus 3 is greater than 4 plus 3, because 5 plus 3 is 8, and 4 plus 3 is 7, and 8 is greater than 7, okay? Same thing with the subtraction property. So if we have A is greater than B, then A minus C is greater than B minus C, and vice versa. If we have A is less than B, then A minus C is less than B minus C. So if we have -3 is less than 5, and we have -3 minus 2 is less than 5 minus 2. So -3 minus 2 is -5, and 5 minus 2 is 3, and -5 is less than 3. So those are just our examples. If we move on to the next page, we're just going to use our addition property. So we're going to solve for x on these. So what I'm going to do is I'm going to write out x minus 15 is greater than -12. So all we're doing is we are getting this x by itself, just like we would use our equal sign in our equations. We're going to use our inequality sign here. So to get this -15 away from this x, we are going to add it to both sides of that inequality sign. And that leaves us with x is greater than 3, okay? So on our number line, we're going to find 3. Since it is just a greater than symbol, we are going to have an open circle, and it's greater than, so it's going towards positive infinity, okay? And just like I said last class, we are going to use our function notation. So the first thing we come across is that 3, and it's an open circle, so we're going to have that parentheses. It's going all the way towards positive infinity, so we're going to have positive infinity, and whenever we're using it at infinity, we have a parentheses again. Let's go ahead and try the got it problem. We're going to have n minus 5 is greater than -3. We're going to add 5 to both sides to get that -5 away from n. That leaves us with n is greater than 2. So we're going to find 2. It's going to be an open circle since it's just the greater than sign, and it's going towards positive infinity. And writing that in function notation, we have an open parentheses 2. It's going towards positive infinity, so we have infinity and close parentheses. Okay. So now what we're going to do is we are going to solve this again. So we've got 10 is greater than or equal to x minus 3. So we're going to add 3 to both sides. That gives us 13 is greater than or equal to x. If we flip this around, that's going to be x is less than or equal to 13. Okay, so all I'm going to do is I'm going to put 13 right in the middle of this number line here. Since it is a less than or equal than sign, you're going to have a closed circle, and it's pointing in the negative direction, so we're going to go to the negative infinity. So when we write this in function notation, we start out at negative infinity, so we have open parentheses, negative infinity, comma, it goes all the way to 13, and because it's that closed circle, we're going to have a bracket. Okay? And when it says graph and check the solutions, all you have to do is pick any number below 13 to make sure it works. So if we have, even if we have 12, if we had 10 is greater than or equal to 12 minus 3, that would mean 10 is greater than or equal to 12 minus 3, which is 9, and that works. So therefore, we know we've gotten it right. Okay, so go ahead and try the got it problem. We're going to have m minus 11 is greater than or equal to negative 2. Since we're trying to get this negative 11 away from m, we are going to add 11 to both sides. It's going to give us m is greater than or equal to 9. So I'm going to put 9 very middle of this number line just because it's easy. We've got greater than or equal to. We're going to close that circle, and it's going towards that positive infinity. And writing it in function notation, first thing we see is this 9, and it's got a closed circle on it, so we have that bracket 9, comma, it's going all the way to positive infinity, and anytime we use infinity, we are going to use that parentheses. And to check it, we need any number that's bigger than 9, so let's just go with 10. If we have 10 minus 11 is greater than or equal to negative 2. 10 minus 11 is negative 1, greater than or equal to negative 2. Negative 1 is greater than or equal to negative 2, so we know we got it right. On our next page, now we're going to use our subtraction property. So we've got t plus 6 is greater than negative 4. So to get this 6 away from t, we are going to subtract it from both sides of that inequality sign. That leaves us with t is greater than negative 10. So we are going to write negative 10 somewhere on this number line. Since it's a greater than sign, we're going to have an open circle, and it's going towards that positive infinity. So our function notation is going to be open parentheses because it's an open circle, negative 10, comma, it's going to positive infinity, and anytime we use infinity, we are going to close it with a parentheses. Okay. On to the next one, we have negative 1 greater than or equal to y plus 12. To get this 12 away from y, we are going to subtract it from both sides, leaving us with negative 13 is greater than or equal to y. And we're going to flip it around so that our y comes first. So we've got y is less than or equal to negative 13. So I'm going to write negative 13 somewhere on this graph. And I'm going to close that circle because it's less than or equal to, and it's going in that negative direction. So first thing we see is negative infinity, so we've got open parentheses, negative infinity, comma, it goes all the way to negative 13, and we've got a closed circle, so we've got brackets around it. Okay. And our last page, we are going to start writing inequalities from some word problems. Okay, so we've got some translating words. So if we have greater than, we can say is more than, is greater than, is larger than, above. If we've got greater than or equal to, we can say at minimum, at least, no more than, or no less than, no smaller than, anything like that. For our less than, we're going to have is smaller than, is less than, below. And our less than or equal to is at maximum, at most, no more than, no greater than. Okay? So the hard drive on our computer has a capacity of 120 gigabytes. So at capacity means that's the most it can have. So I'm going to put just a little note here that capacity means maximum. Okay? And if you've used 85 gigabytes. You want to save some videos on your hard drive. So we want to know all the possible sizes of that home video collection that you can save. So our x is going to be the possible sizes. So our x is going to equal possible sizes. Okay, so we're going to have our possible sizes plus what we've already used on this hard drive, which is that 85. And since it says at maximum, or it says a capacity, which means maximum, that means we're going to have this less than or equal to sign. So is less than or equal to, and then our maximum capacity is that 120. So once we write that, we can start solving it. So we are going to subtract this 85 from both sides. That's going to leave us with x is less than or equal to 35. So if you get here and you realize that maybe you haven't picked the right symbol, inequality symbol, you can always go back and look at it again. But in this particular instance, we know that the biggest number that we can have to put on this hard drive is 35 gigabytes. If we had something different, you'd obviously be able to tell. So we can say that we can have any size less than or equal to 35 gigabytes. Okay, and that's our answer. Our next one, it says a club has a goal to sell at least 25 plants at a fundraiser. So at least, if we go back up to our top, we're going to use that greater than or equal to sign. So that I'm going to put that in a note up here. Okay, so it says club members sell 8 plants on Wednesday and 9 plants on Thursday. So we want to know how many they have to sell to meet their goal on Friday. Okay, so the first thing we're going to do is we're going to add up everything that we've already sold. So we have 8 plants that we sold on Wednesday plus 9 plants that we sold on Friday. And then we want to know what we're selling, or plus 9 plants that we sold on Thursday, excuse me. And now we want to figure out what we sold on Friday. So that's just going to be our P. That's going to be our variable. It could be P, it could be X, whatever variable you want to use. From here, we're going to use our greater than or equal to sign. And the amount that we want to sell is 25. Okay. So from here, we're going to start solving. So the first thing we need to do is combine like terms. So 8 plus 9 is that 17. We've got plus P still is greater than or equal to 25. Okay. Now we need to subtract the 17 from both sides. And that leaves us with P is greater than or equal to 8. So what this means is they need to sell at least 8 plants on Friday to be able to hit their fundraiser goal. So they need to sell at least 8 plants on Friday. And when I say at least, that means that they can sell more. There's nothing saying, well, they can only sell 8 plants, but they need to sell at least 8 plants to be able to hit their goal. If they sell more than 8 plants, that's perfect. They're raising more money than they thought they were. Okay. So that's going to be the end for today. Go ahead and start working on your IXLs.